So one property that was important we talked about with waves is the relationship between frequency and wavelength. Another very important property of waves, that's true of all waves, is that you can have superposition or interference between two waves. So if we're looking at waves and they're in phase, and when I talk about in phase, what I mean is that they're lined up so that the maxima are in the same position and the minima are in the same position, what we can have is something called constructive interference. And all we mean by constructive interference is that literally those two waves add together, such as the maxima are now twice as high and the minima are now twice as low. So you can also imagine a situation where instead of being perfectly lined up, now we have the minima being lined up with the maxima here. So if we switch over to a clicker question, maybe on this screen. Okay. Can it be done up there to switch? Okay. Thanks. Here we go. So we're still settling in with the renovations here in this room. So why don't you all go ahead and tell me what happens if you combine these two waves, which are now out of phase. So let's. Okay, so why don't you all think about what would happen. We'll start with the thought exercise. You can switch back to my lecture notes then if this isn't going. All right, so hopefully what everyone came up with is the straight line. Is that what you answered? Okay, very good. And I didn't make you try to draw the the superimposed positive construction in your notes, but I think everyone can handle drawing a straight line, so you can go ahead and draw what happens when we have destructive interference. And destructive interference, of course, is the extreme, but you can picture also a case where you have waves that are not quite lined up, but they're also not completely out of phase. So in that case, you're either going to have the wave get a little bigger, but not twice as big, or a little bit smaller. So I think the easiest way to think about interference is not actually with light, but sometimes it's easiest to think about with sound, especially when you're dealing with times where you have destructive interference. Has anyone here ever been in a concert hall where they feel like they're kind of in a dead spot, or you don't quite hear as well, and if you move down just 2 seats, all of a sudden it's just blasting at you? Hopefully not in this room. But have people experienced that before? Yeah, I've definitely experienced it too. And really all you're experiencing there is destructive interference in a very bad way. Halls they try to design halls such that that doesn't happen. And I show an example of a concert hall here. This is Symphony Hall in Boston. And I can pretty much guarantee you if you do go to this symphony hall, you will not experience a bad seat or a dead seat. This is described as actually one of the top 2 or 3 acoustic concert halls in the whole world. So it's very well designed such that they've minimized any of these destructive interference dead sounds. So it's nice on a student budget you can go and get the worst seat in the house and you can hear just as well as they can hear up front, even if you can't actually see what's going on. So another example of destructive interference is just with the Bose headphones. I've never actually tried these on, but you see people with them. And what happens here is it's supposed to be those noise cancellation headphones. All they do is they take in the ambient noise that's around it, and there's actually a battery in the headphones that then produces waves that are going to destructively interfere with that ambient noise. And that's how it actually gets to be so quiet when you have on supposedly these quite expensive headphones.